theorem that describes the lengths of sides in right triangles. How could a pattern in triangles have anything to do with circles? Let's see. The Pythagorean theorem states that in any right triangle, if you make squares out of each side, the two squares made from the legs of the triangle together have the same area as the square made from the hypotenuse. No matter how you squash or stretch a right triangle, this will always be true. Let's play with this pattern a bit. We'll take the hypotenuse and lock its length, and pin down one end of it. With that length remaining unchanged, we can consider all of the right triangles that can still be made. If you trace out the unpinned end of the fixed hypotenuse, you'll see that it draws out a circle like a compass. The hypotenuse is now the radius of the circle. And if we think about this in terms of a grid of Cartesian coordinates, the triangle legs define the position of the points on the circle left to right along the x-axis and up and down along the y-axis. For every point on a circle, the coordinates in x and y will relate to the radius of the circle with the Pythagorean theorem. So this tweaked version of the Pythagorean theorem can also describe how to trace out a point in a circle. Instead of locking down the center of the circle at the origin, we could shift it horizontally or vertically. If we offset the center a certain distance to the right, we have to make sure the pattern doesn't mistakenly describe a circle with a bigger radius. So we have to subtract that offset amount from our x location to keep the relationship in balance. If we shift the center up vertically, we'd have to subtract that offset amount from our y location to maintain balance. When you see the formula for how to graph out a circle, remember that you're actually looking at a description